So we're going to talk about sedimentary rocks today. We're going to talk about sedimentary rocks in this module. Different aspects related to sedimentary rocks, but our overall goal here in structural geology is to understand the story that the Earth is telling us, like to kind of reconstruct the history from the clues that are left behind. So we're going to begin just with some basic terminology that we use when we're walking around looking at the Earth's surface. We have something called bedrock. Bedrock is a solid rock that underlies, so the solid rock underlying loose deposits. Deposits. Okay, and so these loose deposits, we could just call basically dirt. There's other terms, sediment, soil, regolith. There's a lot of terms. You don't need to memorize these or anything, but they're good to have heard. Alluvium. This is a U, A-L-L-U, or overburden. Okay, so oftentimes, if you just walk out your front door, you're usually going to find some grass, maybe some soil. If you keep digging, you're going to come to the bedrock eventually, which is this solid rock. And interesting thing, if you think about it, that solid rock is it's the same solid rock in the whole planet, right? You hit that first outcrop, or that first, if you're digging, hit that, you dig down a few feet, maybe you find some solid rock. You could drill through that rock. It connects to all the bedrock everywhere on the planet. So really, we are sitting in most of the Earth is this bedrock, with this little thin bit of sort of dust sort of settled on top of it, basically. So we can divide bedrock into two general categories: soft, which is the sedimentary rocks we're going to be focusing on at first here, and hard. And hard rocks are sort of granites, gneisses. So these are either generally intrusive igneous rocks, or metamorphic rocks that have experienced high temperatures. We also refer to this as the basement. So oftentimes there'll be some if this is the surface of the Earth, there's a tree, there's some dirt, and then under that there may be something that has never really been buried that deeply, but it's a rock nevertheless. So we use this brick pattern for limestone, and then under that there's some like a granite. Limestone. So you're going to want to, we'll use these symbols. You'll see them again. Okay. So typically the dirt, this upper layer, is less than a kilometer thick, and occasionally these rocks will actually stick out of the ground. This might be folded, and we'll find some of the bedrock at the surface. Okay, so we call this an outcrop. But there's other ways to sort of investigate the rocks that are below the surface, below the dirt layers. We can drill holes. We can send seismic waves down. All kinds of methods. But sort of turning back to sedimentary rocks, the soft rocks, there are some basic characteristics that we need to be familiar with, really, to understand what happens to them, sort of to read the signs, the clues that they leave behind. So the first is just the fact that they generally form in beds. So beds are uniform layers of rock. They're often centimeters to meters thick, and we'll look at some pictures of these. And bedding planes, these are the boundaries of the beds. Okay, so there'll be layers. Kind of when you look at an outcrop of sedimentary rocks, you'll see that you can often see kind of certain layers that are maybe slightly different colors or slightly different grain sizes, and they're separated by these planar features called bedding planes. Formation is a group of related beds. And the textbook goes into these terms and a few others in a little bit more detail. And one of the, so we're interested in this in structural geology class, for a number of reasons. But these beds, these sedimentary rocks get folded and faulted, and these layers, the beds, make nice markers. We can see how they've been offset or folded. And one of the sort of most important features involving sedimentary rocks are unconformities. And these are breaks in sedimentation accompanied by erosion. That erosion representing a substantial period of time. Okay, and there are three basic types of unconformities. There's a disconformity. So this is, in this case, the beds above and below they're both sedimentary. With parallel bedding. Okay, so we'll draw some image and diagrams here. So this, again, this would be like a cross section. So there's the surface of the Earth. We're going to find some limestone underneath that, some sandstone. So I'll just do the abbreviations here for a while until you get used to them. Some sandstone. I used the same symbol to indicate sand in the earlier, or dirt in the earlier, just a little bit ago, but typically the little dots indicate sandstone. Here we have some shale. And then maybe we have some sandstone again, okay? But you can see that so this would be the disconformity, this surface here, it's a little bit uneven. But you can see that there's sedimentary rocks both above and below it, and that the orientation is the same. In this case, it's horizontal in both cases. So we call that a disconformity. These are a little bit hard. These can be a little bit hard to spot. It really depends on either having some knowledge of the age, from maybe from fossil evidence, or recognizing a sort of subtle erosional feature. So the next type is a nonconformity. And in this case, the rocks below are plutonic igneous. So that's the plutonic means that the intrusive, the kind that forms underground with large crystals, or metamorphic. So basically, basement. The rocks below are basement. So let's draw a similar cross section there for this one. So here we have some shale, and it's sitting on some granite. And then the last type angular unconformity. So here, all the rocks are sedimentary, but those above and below have different tilts. Okay, so our angular unconformity cross section, put a tree here. Maybe we start out the same, we just have some shale, but then underneath, the layering is the bedding is at some other angle. Okay, so all these types of unconformities, we'll put a little arrow again representing the unconformities. In each case, they represent a time when there was a break in sedimentation and erosion occurring. And this could have lasted a long time. Sometimes these unconformities are on the order of 1 billion years. So if this is all total review for you, you've got no problem with this, you can feel free to skip the YouTube video on unconformities. But if not, the video is pretty cool, even if you've seen unconformities before, have a look at the pictures there, because there are some great examples. But if this is a little bit new for you, then totally watch that video, because there's a nice explanation and examples of unconformities.